Hello, welcome back. In the last video, we discussed about the fundamental theorem of arithmetic and also the prime factorization method to find HCF and LCM of two numbers. We can start with the exercises of that section in this video. Exercise 1.2. First question, express each number as a product of its prime factors. 140, second one 156, third one 3825, fourth one 5005, and fifth one 7429. First one, to find the prime factors of 140, the least prime factor is 2. 70, again 2, 35, here 5, 7. 140 is equal to, the prime factorization is 2 into 2 into 5 into 7, or 2 square into 5 into 7. Second one, to find the prime factorization of 156. 156 is, the least prime factor is 2. This is 78. Again 2, 39. Again 3, 30. 156 is equal to 2 square into 3 into 30. Next one, 3825. 3825, the least prime factor is 5, which is 765. Again 5, which is 153. Again 153, the least prime is 3. 51. 51, again 3, which is equal to 17. 17 is a prime. 3825 can be written as 5 square into 3 square into 17. Fourth one, 5005. To find the prime factorization, 5005, the least prime is 5, which is equal to 1001. Here the least prime is 11, which is equal to 91. Here 7, which is 13. 13 a prime, no more factorization. Therefore 5005 is equal to 5 into 7 into 11 into 13. 5 into 7 into 11 into 13. Similarly, the last one, 7429. We get it as 17 into 19 into 23. Second question, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. First one, 26 and 91. To find the HCF and LCM, first we have to find the prime factorization. Prime factorization of 26 is equal to 2 into 13, and prime factorization of 91 is 13 into 7. Now HCF. HCF is the product of the smallest power of the common prime factor. Here the only common prime factor is 13. Therefore HCF is equal to 13. LCM. LCM of 26 and 91 is the product of greatest power of the prime factors involved. Here the prime factors are 2, 13 and 7. Hence the greatest power is also 1. Hence LCM is equal to 2 into 7 into 13, which is equal to 182. Now HCF into LCM. Here HCF into LCM is equal to 13 into 2 into 7 into 13. 13 into 2 into 7 into 13, which is 2 into 13 into 2 into 7 into 13, equal to 26 into 91, which is equal to the product of this number. Second one, 510 and 92. The prime factorization of 510 is, the least prime factor is 2. 255. Here the least prime factor is 5, which is 51. Here the least prime factor is 3, which is 17. 510 can be written as 2 into 5 into 3 into 17. And 92, the prime factorization of 92 is, 92, the least prime factor is 2, which is 46. again 2, 23. It is equal to 2 into 2 into 23, or 2 square into 23. Now HCF. HCF is the product of the smallest power of each common prime factor. Here the common prime factor is 2, and the smallest power of 2 is 2 raised to 1. 2. Hence the HCF is 2. LCM is the product of the greatest powers of the prime factors involved. Here the prime factors are 2, 5, 3, 17 and 23. And the greatest power of 2 is 2 square, and all other numbers are 1 itself. 2 square into 3 into 5 into 17 into 23. We will get it as 23,460. Now HCF into LCM equal to 2 into 2 square into 3 into 5 into 17 into 23. That is 2 into 2 square into 3 into 5 into 17 into 23, which is equal to 92 into 510. Product of these two numbers. Hence verified. Next question, 336 and 54. Now factorization of 336. The smallest prime factor is 2, which is 168, again 2, 84, again 2, 42, again 2, 21, 3, 7. Therefore, prime factorization of 336 is equal to 2 raised to 4 into 3 into 7. And prime factorization of 54. 54 is, the least prime factor is 2, 27, 3, 9, again 3. 2 into 3 cube. Therefore, HCF, product of the smallest powers of the common prime factor. Here the common prime factors are 2 and 3, and the smallest power of 2 is 2, it's 1, and the smallest power of 3 is 3 raised to 1. Therefore, HCF is equal to 2 into 3 is equal to 6. And LCM is equal to the product of the greatest powers of the prime factors involved. Here the prime factors involved are 2, 3 and 7. And the greatest power of 2 is 2 raised to 4, of 3 is 3 cube, and of 7 is 7 itself. 2 raised to 4 into 3 cube into 7, which we will get 3024. Now HCF into LCM equal to 2 into 3 into 2 raised to 4 into 3 cube into 7. 2 into 3 into 2 raised to 4 into 3 cube into 7, which is 336 into 54. It's given only to verify that LCM and HCF is equal to product. We need not to find the value. Next question. Find the LCM and HCF of the following integers applying the prime factorization method. First one, 12, 15 and 21. Second one, 17, 23 and 29. Third one, 8, 9 and 25. First one, the prime factorization of 12 is equal to 2 into 2 into 3, which is equal to 2 square into 3. Prime factorization of 15 is 3 into 5. And prime factorization of 21 is 3 into 7. Now HCF, here the common factor is 3. The only common factor is 3. Hence the HCF is equal to 3. And LCM, here the prime factors involved are 2, 3, 5 and 7, and the great product of the greatest powers of their prime factor. Here greatest powers are of 2 is 2 square into 3 into 5 into 7, which is equal to 420. Second one, 17, 23 and 29. Here all the three numbers are prime numbers. Hence the only factors are 1 and that number itself. Therefore their prime factorization is 17 is equal to 1 into 17, 23 is equal to 1 into 23, and 29 is equal to 1 into 29. Therefore HCF is equal to common factor 1 only. HCF is equal to 1 and LCM is equal to the prime factors involved in their factorization is those numbers itself. Therefore, their product is its LCM. 17 into 23 into 29, which is equal to 11,339. Next question, 8, 9 and 25. The prime factorization of 8 is 2 cube and 9 is 3 square and 25 is 5 square. Here the common factors of 8, 9, 25 is only 1. Therefore, HCF is equal to 1. Now the LCM is, here the prime factors are 2, 3 and 5. The greatest powers are 2 cube, 3 square and 5 square. Hence their product is the LCM. 2 cube into 3 square into 5 square, or 8 into 9 into 25, which is equal to 1800. Next question, given that HCF of 306 and 657 is equal to 9, find LCM of 306 and 657. We have for any two positive integers a and b, HCF of AB into LCM of AB is equal to a into b. Therefore, LCM of AB will be a into b divided by HCF of AB. See, therefore, LCM of 306 and 657 will be 306 into 657 divided by HCF of 306 and 657 is given, which is 9, which is equal to 20,338. Next question, check whether 6 raised to n can end with the digit 0 for any natural number n. To check 6 raised to n ends with the digit 0, the numbers that ends with the digit 0 are 10, 20, etc. The multiples of 10. Therefore, 10 is a factor. 10 is 2 into 5. The prime factorization of 10 is 2 into 5. Therefore, 2 and 5 are the prime factors of the numbers that ends with the digit 0. But see, 6 raised to n is equal to 2 into 3 the whole power n. Here the prime factorization of 6 raised to n is 2 into 3 the whole raised to n. But the fundamental theorem of arithmetic says that the prime factorization is unique up to its order. So the only prime factors in the factorization of 6 raised to n will be 2 and 3. So it cannot contain the prime factor 5. Hence 6 raised to n is not divisible by 5, or it cannot end with the digit 0. We can see the answer in detail. See, for 6 raised to n to end with 0, it should have the prime factor 5. But the factorization of 6 raised to n is, now 6 raised to n is equal to 2 into 3 the whole raised to n. The only prime factors involved are 2 and 3 by fundamental theorem of arithmetic. Hence, by uniqueness of fundamental theorem of arithmetic, 6 raised to n cannot have a factor 5. Therefore, 6 raised to n cannot end with the digit 0 for any natural number n. Next question, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. To see the solution, we know prime numbers are the numbers that have exactly two factors, 1 and that number itself. And the composite numbers are the numbers that have more than two factors. See, 7 into 11 into 13 plus 13 can be written as, here take 13 common, 13 into 7 into 11 plus 1, which is equal to 13 into 77 plus 1, which is equal to 13 into 78. Now we can factorize 78 as 13 into 2 into 3 into 13, which is equal to 13 square into 2 into 3. Here the factors, prime factors of this number are 13, 2, 3, more than 2 factors. Hence it is a composite number. From this step itself we can say it has factors 13 and 78. Since we are dealing with prime factorization, we can forward to this step. Similarly, next one, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 is equal to, here 5 is common, 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1, which is equal to 5 into 7 into 6 into 4 into 3 into 2 is 1008 plus 1, which is equal to 5 into 1009. 1009 is a prime, no more factorization. Here this number also has more than two factors. Here 5009, 1, and this number itself is a factor. Therefore, these two are composite numbers since more than two factors. Similarly, this one also composite. Last question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? The question is, there is a circular path around a sports field, and Sonia takes 18 minutes to drive one round and Ravi takes 12 minutes to drive one round. The question is, if they start at the same point at the same time and travel in the same direction, after how many minutes will they meet again at the starting point? So it's enough to find LCM of 18 and 12. So to find after how many minutes will they meet again at the starting point, it's enough to find LCM of 18 and 12. Now 18, the prime factorization is 2 into 3 into 3, which is equal to 2 into 3 square, and 12, the prime factorization is 2 into 2 into 3, which is equal to 2 square into 3. Therefore, LCM by prime factorization method is the product of the greatest powers of each prime factors involved. Here the prime factors involved are 2 and 3, and the greatest power of 2 is 2 square, and of 3 is 3 square. Hence LCM is equal to their product, 2 square into 3 square, which is equal to 36. 4 into 9, 36. Therefore, Ravi and Sonia meet again at the starting point after 36 minutes.